Welcome to this explainer. Okay, so we hear all the time about how unbelievably smart large language models are today, right? You've probably seen them write complex software code, break down the nuances of quantum physics, write beautiful poetry, and even pass rigorous medical and legal exams. They seem, well, kind of omniscient. But for all of their staggering intelligence, these brilliant AI models suffer from a surprisingly human problem. They forget. Or actually, scratch that. It's more like they never even knew the information in the first place. Today, we're unpacking this fascinating memory problem. We'll look at how one fundamental limitation pushed researchers to invent a total game-changer in modern artificial intelligence: retrieval-augmented generation. But to really grasp this breakthrough, we've got to look at what the AI world was like before it came along.
Picture this. You're sitting in front of a futuristic, incredibly powerful AI. You type in a super simple question: who won the FIFA World Cup in 2030? Bam! The system just completely freezes up. It can't answer. Why? Because it hasn't happened yet, and the AI literally has no concept of the future beyond what it has been explicitly fed.
Okay, let's try another one. You ask it, what is my company's leave policy? Once again, the AI hits a massive brick wall. Think about this. You've got this brilliant system capable of explaining astrophysics, but it struggles completely with your private, internal business documents.
Let's fire off one final question. What happened in yesterday's stock market? And another failure. The AI is entirely blind to recent real-time events.
So instead of a helpful answer, you basically just get a flashing red warning that says, I don't know. It totally shatters that illusion of omniscience, doesn't it? Despite all the exams it can pass and the code it can write, the AI's biggest limitation is staring us right in the face. If it hasn't seen the data, it is completely 100% in the dark.
Section 1. The magic of LLMs and the closed book test. Let's explore why using an AI is exactly like sitting down for a closed book exam.
You see, when a large language model, an LLM, is trained, it reads billions of documents. It's crunching statistics to build an internal representation of knowledge. When you ask it a question, it doesn't just go search the internet. It simply predicts the most likely next word, over and over, until an answer emerges. But eventually, that training process has to stop, and that creates what we call a knowledge cutoff. This is the exact point in time when an AI model's training ends, and its statistical weights are frozen in place. So the model is deployed to the public, but what happens tomorrow? Say a company releases a new product, a big scientific discovery is published, or a law changes. The model knows absolutely none of it. Its knowledge is effectively frozen in time. Furthermore, if you ask about your company's internal HR policy, well, that answer doesn't exist on the public internet, so it was never included in the training. The model's frozen brain simply cannot know it.
Which brings us to Section 2, the hallucination liability. This frozen knowledge issue leads directly into a major crisis phase for AI developers: the hidden problem of hallucination.
Think about how humans communicate. We usually have the common sense to just admit uncertainty. If we don't know something, we say so. Language models, however, often don't. When a model lacks information, its core programming doesn't just stop. It pushes it to keep trying to complete the text, predicting the next word based on whatever patterns it does know. Researchers call this a hallucination. An AI might spit out a highly confident, incredibly plausible-sounding summary of a manager's report, even if the AI has never actually seen that report. Now, it's not intentionally lying to you. It's just generating text that statistically looks like a correct answer. But if you're a decision maker, generating statistically plausible yet catastrophically wrong answers isn't just a quirky tech bug, it is a severe business liability. It became one of the absolute biggest challenges in AI. How do you give a model access to information it wasn't trained on safely and accurately?
Let's look at Section 3, the million-dollar mistake. To fix this huge liability, researchers initially tried a few brute force ideas, leading to what we can call the million-dollar mistake. The most obvious solution to a frozen model seemed pretty simple. Just retrain the entire model every single time new information appears. Just update the brain, right? Well, that idea crashed into reality hard. Training modern LLMs costs millions of dollars. It requires massive burning clusters of GPUs and enormous computational resources. Plus, the clock is always spinning. It takes weeks or even months to complete just a single training run. It is simply not practical to continuously retrain an AI every time the stock market moves or a new corporate memo is sent out.
Researchers then tried something called fine-tuning, updating the models continuously on smaller loops, but that introduced a completely new headache. The models started forgetting old information while trying to learn the new stuff. Basically, retraining is expensive, slow, and flawed. The industry desperately needed a solution that offered real business value. They needed an efficient, targeted, and cost-effective process. Something fundamentally different, Something much closer to how humans actually work.
That leads us to Section 4, the open book insight. It was time for a major paradigm shift.
Think about how you or I answer difficult questions. We don't memorize the entire encyclopedia. You don't memorize every company policy. Instead, we retrieve information right when we need it. If you need a statistic, you search Google. If you need a document, you open a file. The knowledge doesn't have to live permanently inside your brain. You only need the ability to find it. This single insight changed the entire historical trajectory of AI. In Phase 1, we had static LLMs learning patterns statistically from finite data. In Phase 2, we hit that massive crisis of hallucinations and frozen knowledge. This inevitable tension led directly to 2020 and the formalization of a system that transitions AI from relying purely on fixed training data to relying on external, open-book knowledge retrieval.
Because once you give an AI the ability to actually consult external knowledge instead of just relying on its internal memory, a whole new world opens up. Suddenly, the model can access company documents, cutting-edge research papers, secure private databases, corporate knowledge bases, and even live, up-to-the-minute information. The AI no longer needs to know everything. It literally only needs to know exactly where to look. And here we are at Section 5, the birth of RAG. This was the breakthrough moment, a completely new architecture.
Let's break down exactly how this system, Retrieval-Augmented Generation or RAG, works to secure accurate answers. Step 1. The user asks a question. Step 2. Instead of just guessing, a search system goes out and retrieves highly relevant external documents. Step 3. The language model actually reads those freshly retrieved documents. And Step 4. The final answer is generated, fully based on those newly provided facts, not just statistical guesses. It's elegant, it's cost-effective, and it fundamentally mitigates that scary hallucination risk for businesses.
So RAG solved one of the absolute biggest problems in artificial intelligence by giving these models an external memory. But as with all massive technological shifts, it introduced an entirely new challenge. What happens when the retrieval system finds the wrong information? What if the model reads irrelevant documents or the search itself just totally fails? We've given the AI the amazing ability to open a book, but what if it opens the wrong one? That is a fascinating liability, and it's something you should really be thinking about as these systems become deeply integrated into our daily lives.